to talk about how to remember ascending spinal cord tracks. So, first of all, we're going to have a little pen and paper pre-quiz. So, write down your answers, but don't look at your notes, and it doesn't matter if you get these wrong. But don't spend too long in the quiz. If you can't recall the answer after a minute or two, just move on. The answer will be given at the end of the video, and you'll probably learn something by just watching the video and figuring out what you got wrong. Alright. Okay, so there's going to be a first question, and then there'll be a whole bunch of questions that are together on the same page. And when you get to these bunch of questions, I recommend that you pause the video just so you have enough time to answer them. So here's the first question. Okay, and here are the pre-test questions. Remember, it's probably a good idea to pause at this point. Okay, good job guys. The quiz is now over, and we'll start with the main content. So, ascending spinal cord tracks. So you probably remember from the lectures that you've had so far that there's a difference between the brain and the spinal cord. In the brain, the grey matter is on the outside and the white matter is on the inside. In contrast, in the spinal cord, the grey matter is on the inside and the white matter is on the outside. The grey matter in both contains cell bodies. The white matter in both contains just axons. And today we're going to be talking about ascending spinal cord tracts. And ascending spinal cord tracts are the sensory tracts that send sensory information from receptors to the brain to be processed. And the sensory information coming into the spinal cord to go to the brain comes in via the spinal nerve through the dorsal root and then ascends up in the spinal cord to the respective brain area where it will be processed. So if you look at the image on the bottom right of your screen, this is the spinal cord cross-section, as you already know, and the tracts that we will be looking at today are the dorsal column system, which include the fasciculus gracilis and fasciculus cuneatus, and the dorsal and ventral spinocerebellar tracts, and the anterior lateral system. There are also motor tracts, as you know, where information will come out of the spinal cord via the ventral root to join the spinal nerve. But we won't be considering those here. Okay, so as we've already said, the information ascends from the receptor to the brain. And these are the sensory pathways that we will be considering today. The dorsal column system, the dorsal and ventral spinocerebellar tracts, and the anterior lateral system. It's also important to think about these tracts without having little coloured tags on them, because this is more like what it will be in the exam. You won't have the things that show the relative position of everything, so you need to know, it's easier to know things without having them on, because then you'll be able to do it in the exam more easily when you don't have the different coloured pictures to tell you where everything is. Okay, so the first spinal cord pathway we're going to talk about today is the dorsal column system, and this carries pressure, vibration, fine touch, and proprioception, which is highly localized. So skin mechanoreceptors pick up the information and project it to the dorsal root ganglion. From the dorsal root ganglion, it travels in the fasciculus gracilis, fasciculus cuneatus, depending on whether it's above or below T6. Below T6, it will travel in fasciculus cuneatus. Above T6, fasciculus cuneatus. Below T6, fasciculus gracilis. And then it will project to either nucleus gracilis or nucleus cuneatus, and then cross in the medulla and travel in the medial lemniscus to the VPL of the thalamus, and then to the somatosensory cortex. So here's the little story to remember this. You probably already or have already heard of the Tin Man in The Wizard of Oz. So Tin Man, like mechanical Tin Man, gets on the bus, the dorsal root ganglion, and then gets on the plane because he really doesn't want to walk all the way down the yellow brick road, and gets on the plane, the fasciculus gracilis fasciculus cuneatus, and then projects to the nucleus gracilis nucleus cuneatus, where he lands on the runway high in the mountains, and then crosses in the medulla and projects in the medial lemniscus to the VPL of the thalamus, the bank, because he doesn't have any money because he's been away. And then finally, after all of that travelling along the yellow, and luckily avoiding the yellow brick road, he goes home to the somatosensory cortex. But unfortunately, this is on fire. So let's start from the beginning again. Skin mechanoreceptors, or Tin Man, gets on the bus, dorsal root ganglion, gets on the plane, fasciculus gracilis fasciculus cuneatus, below or above T6, nucleus gracilis, nucleus cuneatus, crosses in the medulla to the medial lemniscus, to the VPL of the thalamus, to the somatosensory cortex. The next tract that we're going to be talking about is the anterior lateral system neospinothalamic tract. So here, free nerve endings in the skin, as opposed to mechanoreceptors in the previous example, project the dorsal root ganglion to the substantia gelatinosa, to the dorsal horn grey, to the cross in the anterior white commissure, to the VPL of the thalamus, to the somatosensory cortex. And the little story to remember this is Neo, sounds a bit like Nemo, projects to Nemo and the boy project to the bus, they get on the bus, the dorsal root ganglion, to substantia gelatinosa, to the dorsal horn grey, the train. Then they cross the road at the anterior right commissure and go to the bank, the VPL of the thalamus, to the somatosensory cortex. So, free nerve endings in the skin, to dorsal root ganglion, to substantia gelatinosa, to dorsal horn grey, to cross the anterior white commissure, to the VPL of the thalamus, to the somatosensory cortex, where the house is burning down. And just for good measure, his house burnt down twice, isn't he unlucky? Okay, ALS paleospinothalamic tract. This carries dull, poorly localized pain. So, polymodal receptors project to dorsal root ganglion, to substantia gelatinosa, to dorsal horn grey, to cross the anterior white commissure, to project to the interlaminar nucleus. This is quite similar to the example before, so just note the difference, that this is the interlaminar nucleus instead of the VPL of the thalamus. And then from the interlaminar nucleus projects to the cingulate cortex. So here's the story. So paleo sounds a bit like pony. The poor pony that doesn't feel very well, gets on the bus, the dorsal root ganglion, to substantia gelatinosa, to the dorsal horn grey, the train, to cross the anterior white commissure, to the interlaminar nucleus of the thalamus, and look, there's a cute fluffy lamb. To the cingulate cortex, or singing. The other component of the anterior lateral system is the anterior spinothalamic tract, and this carries poorly localized pressure and crude touch. So, free nerve endings in the skin, once again, project to the dorsal root ganglion, to the dorsal horn grey, and tract neurons in the dorsal horn grey generate bilateral output ascending fibres that project to the anterior lateral fasciculus. Some of these fibres cross the midline and then ascend in the anterior lateral fasciculus, and some do not cross. They all project the VPL of the thalamus and then the somatosensory cortex. And the story to go with this one is that Spino sounds a bit like rhino, so a little baby rhino gets on the bus, the dorsal root ganglion, and then he gets on the train, the dorsal horn gray, and then he crosses the midline or not, and ascends in the anterior lateral fasciculus, and then goes to the VPL of the thalamus, the bank, and then goes home, the somatosensory cortex. So little rhino gets on the bus, the dorsal root ganglion, then he gets on the train, dorsal horn gray, then he crosses the road or not at the anterior lateral fasciculus, then he goes to the bank, the VPL of the thalamus, and then he goes home to find his house is burning down. The next example that we're going to go through of an ascending spinal cord tract is the dorsal spino or cuneo-cerebellar tract. This conveys information from individual muscles and tendons used by the cerebellum to coordinate movement and posture. Below C8 it's called the dorsal spinocerebellar tract, above C8 it's called the cuneo-cerebellar tract. So, information from muscle spindles and Golgi tendon organs project to the dorsal root ganglion, then to Clark's column below C8, or nucleus dorsalis, it's also known as, or above C8, the external cuneo in the medulla. And this tract is called the cuneo-cerebellar tract. And then they project through the inferior cerebellar peduncle. And the fibers do not cross, and they project to the cerebellum. So the way I like to remember this is by the term muscle man. This is the muscle man tract. So muscle man, muscle spindles in the Golgi muscle spindles and Golgi tendon organs project the dorsal root ganglion, remember the big red bus, to Clark's column. So muscle man gets on the bus, then he goes to Clark's, and Clark's in the UK is a shoe shop. So he goes to buy fluffy slippers from Clark's shoe shop. And then he goes to visit his uncle, and uncle sounds like inferior peduncle, uncle, peduncle. And the fibers do not cross, and muscle man runs into a mouse or vermin, like vermis, like cerebellum. So muscle man gets on the bus, then he goes to Clark's to buy shoes, then he goes to visit his uncle, and then he sees a mouse and is very scared. Let's go through it. Muscle spindles and Golgi tendon organs to dorsal root ganglion, to Clark's column or external cuneate, to inferior cerebellar peduncle, to cerebellum or vermis. The ventral or rostral spinocerebellar tract, conversely, instead of carrying individual muscle sense, carries information about an entire lower limb or upper limbs in the ventral or rostral spinocerebellar tract. So this is primarily Golgi tendon organs, which project to the dorsal root ganglion, the big red bus, to spinal border cells on the lateral edge of lamina 5 to 7. And then at each level of spinal cord, they send axons that cross the midline and descend in the anterior lateral region to the upper pons, and in the upper pons, most of the fibers cross the midline once again to reach the cerebellum through the superior cerebellar peduncle, and then again project to the vermis or cerebellum. So the way I like to remember this is Golgi tendon organs like Camilio Golgi. Camilio Golgi gets on the bus, and if you remember from some of the previous lectures that we've had, Camillo Golgi came from Austria and then Italy, and in this story, Camillo Golgi really, 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 really wants to cross the US border. So he gets on a bus at dorsal root ganglion, and then he crosses the spinal border cells, the US border. And once he's luckily crossed the border, he meets someone extremely superior after he's crossed the border. He meets someone extremely superior, and this happens to be Prince Harry. So he ascends through the superior instead of the inferior, like in the previous example, and then to the cerebellum, and he sees a mouse, vermin. So Golgi gets on the bus, crosses the border, spinal border cells, and then at each level of spinal cord, crosses the midline and ascends in the anterior lateral region, and then crosses again to reach the cerebellum through the superior cerebellopeduncle, and then reaches the cerebellum or vermis. And well done, guys, you've made it through the video, and here are the answers. And tomorrow we will be going through some spinal cord cross sections and just applying what you've learned in this video to what you will see on the exam and in the practical. Okay, thanks for watching, everyone. Bye.